Fracking has opened up huge new supplies of natural gas in the U.S. The most apparent benefits are economic. Studies show that unconventional oil and gas have created more than 1 million jobs and now add over $100 billion to the U.S. economy each year. These numbers are expected to more than double in the next 20 years. The impacts of bringing an industrial process into rural areas are very real. These include increased truck traffic, noise from drilling and fracking, and environmental challenges, but the local economic benefits are very significant. Less expected is that high supplies of natural gas have caused the price to fall from $9 to as low as $3 in the U.S. and are expected to remain low for quite some time. High supply and low price have many industries switching from other forms of energy to natural gas. We're seeing this more and more in transportation, with buses, delivery fleets, taxis, and soon 18-wheelers running on natural gas. Since the emissions of burning natural gas, we know, are just CO2 and water vapor, this has reduced pollution in cities compared to burning diesel or gasoline. Of even greater impact, electricity generation in the U.S. is switching away from coal. We're running existing natural gas plants more since the fuel is cheaper. And new power plants being built are almost exclusively natural gas. We'll talk more about coal later, but one of its downsides is high emissions: SOx, NOx, ash, and mercury. Natural gas produces almost none of these, and it greatly reduces local air pollution. Natural gas produces about half the CO2 of coal as well. In fact, since 2005, CO2 emissions have fallen over 10% in the U.S., down to 1992 levels. It's the greatest drop of any major economy in the world, and it's mostly due to replacing coal with natural gas, along with increased renewables and decreased electricity demand by moving manufacturing overseas. This has contributed to rising CO2 emissions, particularly from China and India, as they're burning more coal to develop their economies. But there are shale gas resources all over the world, and fracking may release new supplies in these areas too, which could prompt the move away from coal, which could reduce CO2 levels globally. Of course, like everything in life, no benefits come without challenges, and there have been environmental concerns with fracking. We'll talk about those next. In simple terms, hydraulic fracturing, or fracking, is the process of pumping water, sand, and chemicals down a well at high pressure to break rock and release oil and gas. It's been used more than 1 million times, beginning in the 50s and 60s, but the process has recently become controversial. One of the concerns is water use. A typical well uses millions of gallons of water, and there are thousands of wells drilled per year. And once the water is used, it's mostly gone. Agriculture, golf courses, and lawns use many, many times more water. But much of it can be reused when it's evaporated and rained down elsewhere. Still, we should attempt to reduce our use of all fresh water as supplies decrease and demand increases. Then, there's the risk of water contamination. Frac fluids contain mostly water and sand. A minor amount, 0.5% to 1%, are additives, gels and soaps to reduce friction and achieve the high pressures required. Acids, mostly to kill the bacteria and mold that can grow on the gel. And alcohol and petroleum distillates to prevent rust that corrode equipment and weaken pipes. There was once a concern that fracturing down here could cause these additives to get into the water table here. But there's over a mile of solid rock between the two. And government and academic studies have shown that this has not happened. Much of the water comes back up the well, now carrying large volume of salts from the rocks, and on occasion heavy metals or natural gas from other formations. When any oil and gas well passes through the groundwater, it's encased in several layers of pipe and concrete, and although very rare, on occasion, natural gas can leak. The more likely source of contamination is wastewater leaked at the surface from trucks or storage ponds. But because these are at or near the surface, they can be contained and fixed, or the offending well shut down. To dispose of this produced water, it's usually re-injected into very deep brine layers. Very rarely, these disposal wells cross geologic faults, making the fault shift earlier than it would have naturally, resulting in minor earthquakes felt at the surface. The fact is, hydraulic fracturing uses and produces a lot of water. Many of the concerns about contamination can be addressed by recycling and reusing that water, which industry is starting to do. To make the most of a rising gas supply, we'll need to continue to reduce water impacts. We looked at the benefits of fracking and some of the water issues. Now let's look at the risks of methane leaks. Several studies in fracking areas have shown that methane, natural gas, is found in people's water wells. We know that methane is naturally occurring in water, so in and of itself, that's not alarming. The chemical signatures of the gas revealed that some came from decaying plant matter, but some came from deeper rock formations. One study found the methane was related to fracked wells. It's rare, but as with all oil and gas wells, on occasion, the concrete surrounding the surface casing can have small cracks, which would allow the methane to leak into the groundwater. While the other studies found that the methane came from gas-bearing formations not related to fracking. There have been other studies that look at methane leaks to the atmosphere. Again, one study found that frack wells release 2 to 3 times the quantity of conventional wells, while others refuted it. This has been the pattern with methane leak studies. 1 or 2 find that frack wells leak more. More studies find they're the same as conventional wells. But the same isn't good enough. Methane is a greenhouse gas, considerably more potent than CO2. If increased supply means we'll use considerably more natural gas, then new wells and new pipeline infrastructure need to leak less than in the past. No one wants the benefits of reducing CO2 to be offset by leaking methane. And that's the heart of the issue with shale gas. There are definitely risks, but no energy is perfect. These are trade-offs for the very significant emissions and economic benefits of natural gas. We need to suspend our biases and understand the facts, and then make and enforce regulations intended to minimize the risks and maximize the benefits.